Welcome to today's Ocean Connector, an opportunity for the ocean sector to come together to discuss, learn, share ideas, and make connections. My name is Melanie Nadeau, and I'm the CEO of the Center for Ocean Ventures and Entrepreneurship, COVE. I have the pleasure today of introducing our panelists, but before I do, I would like to thank our Ocean Connector sponsors, Killen Properties, Cox & Palmer, and our founding partner, Irving Shipbuilding. Before we move into our discussion today, I'd also like to take the opportunity to give a few updates from COVE. First being our COVE intern program. As many of you know, we launched our COVE internship program last May, and it was a resounding success, even despite the challenges posed by COVID. COVE, along with some of our tenants, including Precise Design, Pisces RPM, and Deep Sense, participated in the pilot. We'll be launching our second program in May 2021, and we're starting the recruiting of companies and interns as we speak. So for those that are interested in participating in our internship program next May, we'd really like you to reach out to us, let us know of your interest. And also I should mention that COVE is the one that shepherds a lot of these programs forward and takes care of the students as they go through their 8 weeks or 4-month projects. If you want more information on that program, there's also a video up on our YouTube channel. Next is, sad to say, but this is this year's final Ocean Connector. So in light of that, I'd like to wish everyone an early happy holidays and also give you a heads up on our Ocean Connectors for 2021. They'll look and feel slightly different, and we're excited to let you know and announce who our first guest speaker will be in 2021. So stay tuned. Now on to our panelists. Joining us today is David Shea. He's the Senior Vice President of Engineering with Kraken Robotics, headquartered in Mount Pearl. And fortunately for us, he's also a common face here at COVE in Halifax. He has extensive experience in underwater robots and sensors all over the world. Moderating our panel today, or moderating with Dave, is Aubrey Palmater. You can't see him right now. We're having a bit of a computer glitch, but we're hoping to allow him to join in shortly. And Aubrey is the CEO and President of Eastport Engineering, and also Director on the COVE's Board of Directors. Before I pass it off, I just want to let the audience know if you have questions as Dave gives his presentation, you can put them in the chat section, chat function as part of this call. So Dave, I'm going to pass it off to you. Everyone, enjoy the conversation.
Great. Well, thanks, Melanie, for that kind introduction. My name is Dave Shea. I'm the Senior Vice President of Engineering for Kraken Robotics. Today I'm here in Mount Pearl at our main facility. But as Melanie mentioned, I spend a lot of my time at the COVE facility where we have our unmanned maritime robotics facility there in the north end of COVE. Today I'm going to talk a little bit about what we do at Kraken, where we've been, and where we're going, and hopefully leave you all a little more well-informed by the end of it. And hopefully you can see my presentation here. There we go. So I'll give you a little bit of background about Kraken, who we are and what we do. So Kraken is a relatively young company. We originally started in 2012 in St. John's, Newfoundland. There was about 6 of us at that point. Today we're about 125 people worldwide. We have multiple offices in Canada. Our main office here in Mount Pearl, Newfoundland. We have an office in the COVE in Dartmouth, Nova Scotia, an office in Toronto, one down in Boston, 2 in Germany, and we recently opened an office in Copenhagen in Denmark. So Kraken, is a marine technology company. We're focused primarily on defense, and you can see a number of our customers there on the right-hand side. But over the past couple of years, we've really started to diversify into commercial opportunities, into oil and gas, into offshore wind, and other commercial survey opportunities. We're a highly technical company, as mentioned there. I think we have about 10 PhDs on our team right now. Out of those 125 people, we're mostly technicians, engineers, technologists, software developers, electrical, mechanical, naval architects, and then a relatively small administrative staff. So this just gives you an overview of the different offices that we have and where we're doing different things. So in Halifax, Nova Scotia, or Dartmouth, Nova Scotia, where the Cove is, that's our handling systems group, and as well as our operational center where we do a lot of our sea trials. So you'll actually, if you're over at Cove in the next few weeks, you'll see a number of our folks there conducting sea trials with some of our equipment. You can see the different facilities we have. Where I am here today in Mount Pro, we have about 19,000 square feet. Our office there in Dartmouth, one of our offices in Rostock, and then something I'm going to touch on a little bit later is our own research vessel. That's actually a recommissioned, it used to be an RCMP boat called the Murray, now renamed as the Ocean Seeker. So when I mentioned marine technology and what we do, I wanted to kind of give you an overview of all the different products that we have. So Kraken does a lot of our own modeling and simulation. We do finite element analysis, computational fluid dynamics. We do a lot of our own artificial intelligence software. So we work in deep learning, machine learning. We work in 3D visualization. We build our own sensors. So we have synthetic aperture sonar is our bread and butter, and I'm going to talk a little more about that today. We build our own underwater laser scanner, so an optical sensing system, and we build our own pressure-tolerant batteries, thrusters, electronics, and we combine all those technologies together into complete turnkey systems. Two of the systems I'm going to talk about today are our KATFISH actively stabilized towed system on the top there, and our Thunderfish, which is an autonomous underwater vehicle. So that's an untethered, unmanned underwater vehicle. So back in 2012, when we started a company, we were primarily focused on sensors. We had our synthetic aperture sonar, that was our main product, and we were selling those mostly as aftermarket upgrades to other people's AUVs, so customers, navies, primarily, who already had vehicles out there in the world. We started moving up market in 2016, expanding into building our own components like batteries, thrusters, pressure-tolerant electronics, and then eventually moving up further into where we're building complete platforms and systems. So we have our KATFISH system and our Thunderfish system. More recently, we've been diversifying our business away from just purely product sales into actually operating what we call RAS and DAS, which is robotics as a service and data analytics as a service. So those businesses are where we're taking our robots, we're taking our sensors, we're taking all these systems out into the field. The people who are designing and building these systems are actually out there operating these systems, collecting information and collecting data, and then providing that data to the end customer. So rather than having to actually purchase and deal with the life cycle costs of this equipment, you can have us go out there and collect all that information for you. So this is just an overview of kind of the growth of our business. It's been very, very rapid. In the past couple of years, we've almost doubled in size. So there's been some significant growth. Our growth has been a combination of organic, where we just naturally hired people on and added more bodies, as well as some acquisitions that we've done. For example, in Rostock, we actually acquired a business there, or where we found teams, for example, in Halifax, when Rolls-Royce was shutting down their operation a number of years ago, we stepped in and we hired on a bunch of their senior engineering team to help start our handling systems group. So it seems like we do a lot of different things, but all of these technologies, all these products, all function together holistically to really provide that top to bottom turnkey seabed imaging service. So one of the things that I mentioned was defense. We work a lot in mine hunting, we work a lot in mine countermeasures, and a question that we get from people who aren't involved in that industry is like, well, why do you need this high resolution technology? Why do you need these specialized tools to be able to go and find mines? Well, traditionally, people think mines are these big spiky balls, you know, that we all see in the movies from World War II. Well, today, modern mines are completely different. They're small, they're acoustically quiet, they're designed to look like rocks, sound like rocks, they're designed to wait and ignore all the other vessels until the one target of opportunity comes over top. So what we need is very, very high resolution imaging tools to be able to differentiate what's a rock, what's a mine, be able to identify these targets, and then you choose as an operator whether you want to blow it up or whether you just want to avoid it. And just at the bottom here, you can see some of the people who are actually using our systems. The Royal Danish Navy and the Polish Navy are two very large customers of ours using our KATFISH systems. And we have a number of systems working down in the US as well. So I mentioned synthetic aperture sonar, so to give you a very brief crash course in that. Synthetic aperture sonar is fundamentally a side-looking sonar system. So one of the principles of a side-looking sonar is you have a beam that spreads, or it gets larger the further away you get from the platform. So one of the problems with that is the further away you are from the platform, the worse the resolution is. What we do with synthetic aperture sonar is, as the vehicle is moving through the water, whether it's an AUV or a towed system, we're actually pinging and sonifying the same spot on the seabed again and again, or we're overlapping. And then we can combine all those pings together to make it look like it comes from one very, very long array. So what that allows us to do is, as we get further and further away from the platform, instead of that beam spreading, we just artificially make the array longer and longer, which allows us to maintain a constant resolution. So with you can see, and this is some real data that we've processed, typical side scan sonar systems, you can get a very high resolution image at short ranges, 5 or 10 meters. But that image degrades the further away you are from the platform. One of the unique principles of synthetic aperture sonar is that the resolution is constant, regardless of whether we're 100 or 200 meters away from an object or 2 meters away from an object, we're generating the same resolution. And that's a 2 centimeter by 2 centimeter pixel that we're generating using just sound. So ultimately, that gives you a much larger, what we call an area coverage rate, meaning we can cover a larger area in a shorter period of time at a very high resolution. For those of you in Nova Scotia, this is a much more nearby example. These are actually Volvos that were dumped in Halifax Harbour back in 1969. So you can see on the bottom right, there's an image with a traditional mine hunting sonar system at about an 80-meter range. Now, that tells you, well, yes, there's an object there, but I don't really know what it is. Is it a rock? Is it man-made? Is it a piece of structure underwater? At exactly the same range with the synthetic aperture sonar, we can very easily tell these are cars. We can see the doors are open, we can see the engines have been removed, we can see the tires are gone, and we're starting to see the roofs actually collapsing. So we use these targets. These are in Bedford Basin. They're in about 60, 65 meters of water. We use these targets over the past few years as a great resolution test for us. And we've actually started to monitor the degradation of these targets over time. So yes, we can make beautiful pictures of the seabed, but why does that matter? So this is an example of some work we did last year just outside of Halifax again. This was collected by the Canadian Hydrographic Service, and this is a ship hull mounted multi-beam system. So this would be a standard kind of seabed imaging or seabed mapping sonar for them. So in about 45 meters of water, this is generating about 1 meter by 1 meter pixels. This particular object, we were partnered with CHS. Everyone was looking at this data thinking, well, we think this is a man-made object. It doesn't look natural. Given the general area it was in outside Halifax Harbour, there was a high suspicion that this was the HMCS Esquimalt, which was the last Canadian warship sunk during World War II. So CHS gave us this data, and they said, well, can you take your sonar out there, and we can use this as a test and see, well, what is this object, if you can get us a higher resolution picture. Well, our synthetic aperture sonar, not only does it generate that very high resolution image, we can also generate bathymetry from the same thing. So when we went over that system with our sonar, this is what we found. So our bathy is about 12 by 12 centimeters in this particular image. First of all, definitely not a warship. It looks like a very large subsea structure or some kind of shipwreck. But at the same time, we're also collecting this 2 centimeter backscatter. And this is all collected in real time as we're towing our system past this object. So very clearly, it's a barge. It's a very large barge, an 80-meter long barge, and it wasn't marked on any charts. There's no record of it. So it was still a very interesting discovery for us. But one of the principles and the demonstration that this did for us is showing that even if you're out there doing this type of bathymetric mapping, why not be using this type of sonar all the time? Even if you might not need the resolution for hydrographic purposes, you already have it. You already have that data through the nature of using the synthetic aperture sonar. So this is one of our other products that we've built here in Newfoundland and where we demonstrated in Nova Scotia. This is our underwater laser scanner system. And I'm hoping the video plays through the link here. So here we're actually using, as opposed to acoustics, we're using an optical camera and a laser, and we're illuminating the scene with a red light and a green laser so they don't interfere with one another. And then we're producing a real-time 3D point cloud of the objects. So whereas the sonar image I showed previously is about 2 centimeter resolution, the optical system works down to about 0.9 millimeter resolution. So we use this for inspection of objects when we really want to get a very high resolution image of a target there. The interesting part of generating those point clouds, in that case it was a mooring chain, the pretty picture is all well and good, but what we're really interested in is the information that data can generate for us. So what we've done here is we've actually fit a model of that mooring chain to the data, to the point cloud, and then we've done a subtraction. So what you're seeing in this colorized picture is anything that's blue is actually below the diameter of the model, meaning that it's corrosion or pitting on that chain. Anything that's red is actually above the diameter of that model, meaning that it's probably biofouling, or it could be some accumulation or some growth on the chain there. So this gives us a very fast, quantifiable way to look at these types of objects. This is another example where we did an inspection of a ship hull using the same thing. So now we're hovering on an ROV here. The ROV is moving a little bit in the water, and the laser is actually on a little servo, and it's sweeping over. And it's producing this point cloud in real time. So we're inspecting the propeller, we're looking for any dings or dents or cavitation in the prop, we're looking at the anodes, we're looking at the generalized condition of the hull. And what's really interesting about this is for anyone who works in the shipping industry, when you send the diver down to go look at your anodes, generally they're coming back and they're giving you, well, your anode is 25, 50, 75, or 100% intact. It ends up being a very qualitative measurement, and it's very costly and it's dangerous and time consuming for divers to do this type of work. With a laser scanner system, not only can we provide a quantifiable measurement of exactly how much is left in that anode, we can tell you there's 54.9% left, but because we can do it so quickly and quantitatively, then we start entering into what we call predictive analytics, whereas I can scan all the anodes on your ship and I can tell you if I scan it every month or every 6 months, well, the port forward anode is always corroding a little bit more than the other anodes on the vessel, or a little bit faster, meaning that there must be an issue somewhere in the hull on that particular section. So then we can start to actually predict failures before they happen. And we can do this, unfortunately, this is just not a video, just a screenshot, but we can do this across the entire hull of a vessel. So we're able to inspect all of the anodes, and what you're seeing here is that same scan that we did previously, we've stitched together a bunch of these different scans across the whole surface of the hull. And we're measuring, you can see the bow thruster on the nose, you can see all the anodes popping out there, and then the propeller on the tail. And the reason we only have one side, in this case, the vessel was actually tied up to a pier, so we weren't able to access the other side of it. So I mentioned that we delivered, traditionally we delivered most of our sonar systems to other people's vehicles, other people's AUVs. This is just a sample of some of the different systems. So we've installed synthetic aperture sonar on all of these different platforms. Some of them have come directly from the manufacturer with our sonar on board. Most of them are an aftermarket where we have a customer who wants to upgrade their system essentially, and we can bolt this on. To provide another example of that, this is a program we're involved in the US where we take the synthetic aperture sonar payload, you can see that gray payload there, and it's actually designed to be a wet fit onto the nose of any one of these vehicles. This is called a Remus 100, so it's a small man-portable vehicle, so it's about 7.5-inch diameter, weighs about 80 to 100 pounds, depending on how much gear you've got installed onto it. And we can, not only does the sonar fit onto that vehicle, it can actually be removed and fit onto any one of these vehicles, so it becomes a very modular and easy thing. Like this could be sent into the field with naval support to be installed on any existing platform. So selling sonars to other people's vehicles, that was doing us well for a while, but as I mentioned, we wanted to move up market. We wanted to get into building our own turnkey platform. So this is where we started with the KATFISH, which is our actively stabilized towed sonar system. So you can see a few of the KATFISH systems there in production in our facility in Mount Pearl. The KATFISH is actually designed for unmanned surface vessels. So it's an intelligent, actively stabilized system. The main depressor wing there is fixed. The tail fin, all those four actuators are independently controlled. The reason we put them in that X configuration are so that if one of them is damaged or one of them breaks, then the other three can still maintain 3 degrees of freedom control over the system. So that whole system is designed to be actively stabilized, meaning that as the boat's moving around on the surface and it's hauling on the cable, rather than just having to use a big heavy weight to damp out the motions, the fish can actually sense all of those motions and stabilize itself underwater. It also has the benefit of a forward-looking sonar, so it can do obstacle avoidance. It can actually rise up over objects, or if it's coming up towards a seamount or something like that. And we've also integrated the laser scanner system, so the same optical laser that I mentioned previously is integrated into the belly of the fish there. It's meant to be field maintainable, so all the parts, it's a wet flood system, and all the components inside can actually be removed and replaced in the field by a trained operator or a trained technician. We also have our Thunderfish system I mentioned. This is our autonomous underwater vehicle. So unlike the KATFISH, which is towed from a surface vessel, the Thunderfish has its own batteries, it has its own thrusters. You drop that off of a vessel and it can swim down to the bottom of the ocean, and it can do a survey, it can look for an object, it can search for a shipwreck, it can do a pipeline inspection. One of the unique aspects of the Thunderfish project, or the Thunderfish is actually designed to be seabed resident. So it's meant to actually live in a garage on the seafloor for up to a year, and that garage can either be tethered to a shore station where it can be fed power, or the garage itself can have a huge bank of batteries. So the Thunderfish can swim out, do a mission, come back, download data, recharge its batteries, and keep doing that over the course of that whole year. So as I mentioned before, all these systems are vertically integrated. So the Thunderfish is using our sonars, our batteries, our laser scanners, our thrusters. The majority of components in the vehicle are designed and built by Kraken. There's a number of things in there that we know what we do well and we know what we don't. So there are some things that we buy externally as well. And then the Ocean Seeker, which I'll talk a little bit about, this is our own vessel. So it's a catamaran, an aluminum cat, so it's got twin hulls. It was originally an anti-smuggling vehicle or vessel. This was actually working off the south coast of Newfoundland for a number of years, between Newfoundland and Saint-Pierre-Miquelon, which is French territory. So the Ocean Seeker is really interesting for us, not just because we really wanted to have a boat, but because it gives us an opportunity to testing our own equipment, using our own tools. So we developed, specifically in Nova Scotia, we developed something called the Autonomous Launch and Recovery System. So the ALARS is designed to safely and efficiently not only launch and recover the KATFISH without any human involvement, but also the winch and the fish and the overboarding system are all talking to each other all the time. If the fish is trying to fly up and it needs pulling cable, it can actually command the winch to pulling cable for it. Vice versa, if the fish is trying to get down to depth, it can actually command the winch to pay out cable for it. When it's being launched and recovered, the winch, the fish, and all those components are talking to one another to safely bring the fish back into the docking head to recover it and then bring it back on shore. So this is the ALAR system actually installed and tested at the Cove on the board. You might recognize the background there. This is on the Ocean Seeker. So this vessel, when we did the original testing, you can see we had it strapped down to the back of the deck. Since then, the Seeker's actually gone into refit, and she should be back at Cove within a week or so, where we now have all the hard points mounted to be able to permanently install all of that structure. So all these technologies and tools and images are really cool, but what are we actually doing with it all? Well, there's a big project that we're part of under the Ocean Supercluster called the SeaVision project. So that's where we're taking our tools, we're taking the KATFISH, we're taking the Thunderfish, we're taking our laser scanners, we're taking our sonars, we're going in and around Atlantic Canada, and we're collecting large volumes of data with these robotic systems and performing analytics on that data with the ultimate goal of providing that data as a service to all of our project partners. So we have participation from oil and gas industry, we have participation from the offshore fishing industry, and participation from government groups as well. So that's about a 3-year project. So we're about halfway through that right now, and we've just wrapped up one of our recent campaigns, just working in the offshore. So the whole purpose of that project is to demonstrate not only that we can go out and get pretty pictures of things, but that robotics can actually help us collect larger volumes of data at a much, much lower cost and much more efficiently than traditional methodologies using ship hull mounted multi-beam or ROVs and things like that. So I'm going to show you a little piece of data we just recently collected. So this is an example of a mooring chain. So you can see the individual, this is a sonar image. So we're imaging from one side here. You can see the individual links, and the links look fairly small there. These are about 80 centimeters, 90 centimeters, so almost a meter diameter, every one of these links. But what's really interesting is we can see the placement. We can actually see some of the free span here, so we see the links are actually hanging out over the edge of that berm. And then we can zoom in on one section here. We can pick out a particular piece of that data, and we went over the same area with our laser system. And so the same data that I showed you previously, we can go from that 2 centimeters all the way down to that 0.9 millimeter resolution. And this is where we've done that same model subtraction that I mentioned before. And I'm not sure if you're able to see it over your screens, but you can see there's a few sea stars, there's a couple of crabs there that actually show up as red because they're larger than the diameter, because they're actually sitting on top of those links. So that's kind of a crash course in who we are and what we do. And I'm glad to see Aubrey's online with us here now. But I'm happy to open up to questions and further discussion and listen to our other panelists.
Thanks, Dave. Can you hear me, by the way? Roger that. Good. Sorry for the diva-like, fashionably late arrival. We had a little technical issue. I was going to start off with the Ocean Seeker questions because I can watch it out of my window, but you've pretty much answered those questions. I'll move on a bit in the absence of any questions from others. Before I do that, though, I just popped up on the screen here. I should probably tell people who I am. I'm Aubrey Palmater. I'm on the board at the Cove. I'm the president of East Point, engineering firm with activities both in terrestrial and water-based activity around Atlantic Canada and indeed across the country. So without but you didn't come here to hear me talk. You want to hear from Dave. Dave, maybe you could talk to us a little bit about some of your recent successes in Denmark and Poland, and what the Navy there seems to be a strong market for your technologies. Can you project a little bit about how that's going to evolve and what the opportunities for you might be there?
Definitely. Yeah, so as you mentioned, we recently won a couple of major contracts, the largest contracts we've ever won. I think the total is around $50 million or so between Denmark and Poland. Denmark in particular is particularly interesting for us because the Danish Navy has been using unmanned mine hunting systems for over 25 years. These are large vessels. They're about a 25-meter vessel. They're remotely controlled, so they can drive them over a radio link from a mothership or from a shore station. And the sonar systems that they were using for their mine hunting operations, they're 25 years old. Technology has evolved a lot, so they went through a competitive procurement where they put out specifications. We bid on that against some major prime contractors. Some of the largest defense companies in the world were bidding on that program. They specifically called out not only synthetic aperture sonar for that particular program, but also unmanned launch and recovery. And part of that bid process, part of that program also involved doing an evaluation. So it wasn't just a paper bid. We actually had to have the Danish Navy came to Halifax. We did a demonstration in Bedford Basin. We deployed a few targets there and demonstrated that the system, the launch and recovery system, the fish, all the gear that we have is real, it's tangible, it really does work, it really does perform. So we were very happy when we won that program. The interesting part for us, of course, we're happy we won a contract and we're going to build more things and hire more people, but the relationship there is really important for us because the Danish Navy has an enormous amount of experience in mine hunting as a NATO nation, and they're by far one of the world experts in that capability. So for us, that relationship and that partnership will help us demonstrate our products. It'll help improve the capabilities that we have, and ultimately will help us to export that capability worldwide. So one of the reasons that we've set up that office in Copenhagen in Denmark is we're actually intending on starting a center of excellence in mine countermeasures in Denmark, specifically leveraging the experience and the knowledge of the Danish Navy as a prime customer.
Great. So I love Copenhagen. It's a great spot. And you're focusing on robotics as a service there, as I understand it. And I think that's wise because it allows you to kind of control the technology. Do you still intend to sell technology as pure technology as a product, or are you looking at robotics as a service as the primary vehicle for expansion?
So we absolutely intend to continue selling products. There's always going to be customers that will want to own, the complete system themselves, and navies are a great example of that. When they're out working in real world scenarios in challenging environments, sometimes threatening environments, they have their own sailors. They need to be able to use their own tools. They need to be able to maintain their own tools. So we will continue to sell systems, products, and solutions to mostly defense customers. Where we see the service capability is where there are customers in defense and in the commercial industry in particular, where they don't want to have to take on the life cycle costs. They don't want to have to go through all the training. They may not have the capital budgets, and maintenance and repair is a good example of that. People are obligated, operators are obligated to inspect pipelines, inspect moorings, inspect offshore infrastructure on a regular basis, whether it's every 6 months or every 2 years, depending on the country. They want to be able to go out there, but if you're only doing that survey once every 2 years, it doesn't make sense to have all the people trained up and operating that capability. So that's where we can step in and bring this technology, and not just bringing an old sonar system, an old side scan system, or an old multi-beam. We're bringing cutting edge defense technology into those sectors at a very competitive price. And when I say competitive price, one of the main benefits there is that the way we were able to make it very competitive is we don't require so many people. And when you don't require so many people, you don't need as large of a vessel. And we don't need as large of a vessel, we can reduce costs, we can reduce the carbon footprint, and we can increase the quality of the data that they're getting out of it. So that's kind of the split between those two business models for us.
So international rules are a little different than the genteel Canadian world. If you're out there with your technology and it's available, aren't you a little worried that somebody might reverse it and steal it from you?
So generally, if people are trying to reverse engineer or trying to steal our technology, it means we've done something right. So that's a good sign. There's always going to be people following behind us. Technology is continuing to evolve. At Kraken, we have a particular mantra: innovate or die. Our mentality is to constantly keep developing, keep innovating. It's not, the KATFISH is a perfect example. The KATFISH that we have today is better than the KATFISH we had 3 years ago. Most of those changes, most of those improvements are software, but there are some optimizations that we've done in the hardware to make it easier to maintain, easier to manufacture. So that whole concept, and synthetic aperture sonar is another good example of that. We're not the only people in the world that build synthetic aperture sonar. It's just that traditionally it's been reserved for very, very high priced defense applications and built by very expensive tier 1 defense contractors. One of our objectives is really the commoditization of technology. And a good comparative for that is the aerial drone industry, where we've seen, 15 years ago, 12 years ago, there were drone manufacturers in Canada that no longer exist, because as soon as, when you're buying parts from China and parts from Korea, you're buying batteries, you're buying motors, you're buying cameras. Eventually those manufacturers realized, well, they should just build the complete drone themselves and actually sell it. And now, whereas a drone used to cost $20,000, $30,000, $40,000, now you can go to Best Buy and you can buy one for $300 on your credit card. Underwater technology is a little bit more challenging than that, so I don't see quite the same pace of commoditization, but we're certainly keen to see other people doing it and other people pushing into that sector, because it'll continue. One, it forces us to be better, it forces us to continue to innovate, but it also makes a lot of the parts that we're using, subsea cables and connectors, for example, we don't build those ourselves, we buy those from other manufacturers. So as that commoditization happens, those parts will get cheaper for us, and we'll ultimately be able to deliver a better, cheaper product.
Yeah. Great answer. I'm going to shift gears away from technology back to more business questions. You went public a couple of years ago in TSX. Can you just talk to us about how that's changed your business and where you see that going?
Yeah, so we took the company public in 2015. We're on the Toronto Stock Exchange, on the Venture Exchange specifically. So we've been public for 5 years now. It's been an interesting ride for sure. A lot of the regulatory components of being public, meaning that we have to submit audited financials both quarterly and annually. There's a lot of, I wouldn't say challenges, but just some things, some learning, teething pains that we had in the early days. The benefits of being public are that it's enabled us to access a very large pool of capital to fuel our growth. So we've been able to go from 6 people to 125 people. We've been able to take on some very large projects. The Thunderfish and the KATFISH projects, for example, those are funded by a combination of both our own capital as well as support from the National Research Council's Industrial Research Assistance Program, support from the Ocean Supercluster, support from a number of other government programs. But it's not 100% dollars. We're always putting our own money in there. And when you're talking about spending millions of dollars developing this technology, well, that money has to come from somewhere. So being public has enabled us to really accelerate our growth and to get to where we want to be faster than we would have otherwise.
Another good answer. What did you say your employee count was? Did you say 100?
We're about 125 people right now. I think when a few more job offers clear, it will probably be 130 by the end of the week.
So that's up 3 or 4 times from where you were a couple of years ago. How just talk to me a bit about how hard it is to find people, especially people with the technical talents that you need. Clearly that's a requisite, I would think, to being successful with your business. So how is that HR side going, in St. John's and in Halifax and elsewhere for that matter?
I think recruitment of good people, the classic example, good people are hard to find. That's definitely true. We have the unique advantage where we started in Newfoundland. We have a large offshore sector. We have a fantastic engineering university and Memorial University. So we've been having a continuous cycle of co-op students or interns with our various engineering teams over the past years. And that's really been one of the best organic strategies we have for recruitment is we bring students in, they work with us for 1 or 2 terms, for 4 months or 8 months. And if they're good and we've trained them well, when they graduate, then we bring them on board and they can hit the ground running. They've already learned our processes, they've already learned our products, they're familiar with our technology. Internationally and in our other offices, we've been very opportunistic. We seek out talent. We work with universities. We work with various research institutions where people are looking to bridge out into industry. So there's been some great opportunities there. But I think really building a very positive, ambitious, and innovative culture has driven a lot of people towards us, actually, and that's been a big benefit for us. That and having multiple offices in different locations. So it's not like I've got 125 people in St. John's. We're able to recruit, and COVID has been a great demonstration of the capability of remote communication. Today, if I'm going to hire an engineer, it doesn't really matter if they're in Nova Scotia or Newfoundland or Toronto, as long as they're able to connect with a computer, as long as they're able to interface with our teams, then they can come online, they can be productive, and where you live doesn't really matter as much as it used to.
Right. Are you finding you're hiring more postgraduates, or is it first degree level employees primarily? How's that working?
So we have kind of a mix, as I mentioned. We do have a highly technical team. We have a number of PhDs. I think we have 10 or 11 PhDs on our team right now in various groups. So some working on our machine vision and artificial intelligence systems, some working on our underwater vehicles and control systems, and some working on our sonar systems, specifically around our synthetic aperture sonar. So there's been definitely a mix there. We also have, in terms of our engineering group and our production team, our production technicians tend to come out with a 1 or 2 year technical diploma, whereas our engineers are coming out of a 4 or 5 year engineering program. And generally, we encourage our engineers to become professional engineers. Myself, I'm a registered professional engineer in Newfoundland, and that's also been to your previous question about recruitment, that's been a great opportunity for us as well, because it exposes us to students while they're still in their undergraduate programs, to be able to connect with them, to be able to talk to them about what we do and what they might be interested in.
Excellent. Have you been using the Canadian government export support structures like EDC or CETA or others? Can you just speak to that for a bit, just to give people a sense for how that's been helpful?
Yeah, the two things that we've most recently leveraged, one being CETA, the Canadian-European Trade Agreement. So when we're bidding something in Denmark, for example, and a quite literal example, when we're selling things into Denmark, there's a condition that says it must be delivered duty paid. Between Canada and Denmark, there is no duty. between the US and Denmark, they would have to pay duties on those products. So that gave us, it's not a huge amount of money, but it's still that small advantage in those bid programs. In terms of the actual government export support, we work with EDC very regularly because most of our sales have been international. So we're delivering products to customers all over the world. EDC has helped to backstop the performance guarantees and bank guarantees that generally we have to issue when we're billing customers for advance payments, when we're delivering products. It's also been very helpful for us because of any export restrictions, navigating I think it's Global Affairs now is their name that we deal with, navigating the various export restrictions, because it's different country by country, whether we're sending things to Germany, France, Australia, the US. We very intentionally designed and developed our products to not be export controlled. So if you look at the ITAR restrictions, which is the International Traffic on Arms regulations, our products are below the threshold of, whether it's resolution or depth rating or what have you. We're below those thresholds so that we don't have any export restrictions when we're selling products around the world. So all of those different capabilities, and I think especially here in Newfoundland and in Nova Scotia on the East Coast, like we'd probably be starving if we were trying to sell all of our products here at home. I think that we've been supported by a lot of the government programs and government agencies to export all around the world. And one of the things that we say a lot, not only from an export perspective, but from a demonstration perspective, if you can make something work in the North Atlantic, you can make it work pretty much anywhere.
Right.
So there's been a lot of that very positive support for export and be able to get things out there around the world.
Exactly. I don't know whether you're going to tangle with this one or not. You've just signed an agreement with the Danish Navy, and we may have competitors out there listening to this. So if you pass, that's okay. You've said EDC was a player in that, as well as CETA. Can you just speak to what other things that might have made a difference there? That had to be a very competitive proposal, and I know you deservedly won it, but it clearly had some secret sauce in there. Can you just try, without disclosing any state secrets, to talk about what the secret sauce was, in addition to perhaps the EDC support?
I think, forgetting about all the export restrictions or what country might have been bidding into those various programs, it was really price and performance. That's what won us that program. Not only did we have the most economical price compared to some of our competitor systems, but the performance was at the same level or better than all of the competitive systems. In that particular procurement, the Danish Navy was very prescriptive. They know what they wanted. They've been hunting mines for 25 years. They know what the technology is out there, and being able to do not just bidding in a piece of paper, but having that user evaluation phase as well. So they came to Halifax. We put them on a boat. We ran the system. We had 2 days with them. So the first day we demonstrated it for them. The second day they actually got to use the technology themselves. And I think that's one of the things that really set us apart. Although everyone was subject to those demonstrations, we could prove everything that we claimed in our bid was real. We have a real fish, we have a real winch, we have a real launch and recovery system. It actually works the way that we said it was going to work. It actually has all those capabilities. So I think that's what nudged us up over the line, is really that not only having that performance and bidding that performance, but being able to demonstrate that performance as well.
Another great answer. I have one last question. I'll let you off the hook if you give us a good spin on this. You guys were involved in the Franklin expedition, which had to have been a very exciting experience. Can you just maybe close with some anecdotes and some stories about how that worked and the excitement of it?
Absolutely. That was certainly one of the most exciting points in my career. In 2014, we were invited to go up on the Franklin expedition with DRDC was operating their AUV with our sonar on board. So not only were we invited, but I had the unique opportunity to be able to go myself. So I spent 3 weeks in the Arctic, bouncing around on a ship, running an AUV, looking for Franklin's, the Erebus and the Terror. any shipwreck search, any search and salvage operation is always particularly frustrating, because it's not so much based on, you know, how good your technology is, or, you know, how good your robot is, how good the imagery is. It's all about whether you're looking in the right place. And it's like looking for a needle in a haystack, but you don't know where the haystack is. So, you know, we collected some fantastic imagery up there. And one of the other aspects of this is Victoria Strait, where we were working. The charts up there are basically just white. And for anyone who's seen a nautical chart, much like you would have a topographical land chart, you would normally have contour lines, you normally have all these soundings that mark out what the seabed is. In the Victoria Strait, there's basically 2 lines of soundings right down the middle of the strait. That's the only data that exists in that area. So, and the strait is kilometers wide, and yet every ship that transits through there only goes on these one little paths, because that's the only spot that's been mapped. So it was particularly exciting and a little bit frustrating, because we're out there and we're trying to convince, you know, the captain of the vessel to move further off the line so we can push the AUV out further into the field and further into the area we're looking. But he's looking on the chart saying, well, I've got no idea what's out there. There's no way I'm going to take a ship full of people anywhere into these regions. So every day up there was really exciting, really interesting. It was also very, obviously, a bit restrictive. We weren't allowed to share the results with other passengers or with other parties. So there was a lot of security and protocols in place. But ultimately, at the end of the day, we collectively, all the team Parks Canada, who had been up there looking for it for 6 years, between them and us and DRDC and the Navy and all the different people involved, we were able to discover first the Erebus in 2014, and then later Parks Canada went back to go for the Terror. What's really exciting now, I mean, that was 6 years ago. We're still very actively engaged with Parks Canada, and we recently just completed a Built in Canada innovation project with them, where we're delivering our laser scanner systems onto one of their ROVs, and the intention is that they're going to use that to go up and actually scan those ship hulls, or scan those wrecks, and provide a 3D point cloud, much like what you've seen in my presentation here today, of not only the outside of the wreck, but the inside as well, and be able to provide a virtual training experience, or rather a virtual learning experience for students all over the country and really all over the world. So it's really exciting to see that kind of come full circle, and to be able to redeploy our next generation of technologies up there.
Absolutely. Did everybody burst into a rousing rendition of Stan Rogers' Northwest Passage? Connected?
Yeah, there were many beers drank that day, I can tell you that.
Good for you. That wraps up the questions from the audience. I missed the front end, so I'm not sure exactly what you and I have to do to segue off the stage here, Dave. Presumably Melanie's going to show up here somewhere. Oh, look at that.
Great.
Just mentioned who she is. Hi, Melanie.
Hi. Thank you, Dave. Thank you, Aubrey. That was an excellent discussion, conversation. I've always been amazed at the work that you guys are doing, Dave. So look forward to seeing you here shortly. I just look out the window because I can see, no, I can't see your vessel right now, so only Aubrey can.
It'll be back next week.
It's in refit or something. You got to need some work done.
Yeah, probably. Great. So excellent discussion. Thank you both. So just in closing, to everyone that's watching, I just again will mention that this is our last Ocean Connector. Our next one will be in January. So stay tuned for that one, where we'll go 10,000 meters down under to the bottom of the sea. Cheers, everyone. Bye-bye.
Thank you. Bye-bye.
Thank you.